We're now going to talk about something called eutrophication. Eutrophication. And it comes from, or it's derived from, the Greek for well-nourished. Eu referring to well, and then trophic or trophia referring to nourished or nourishment. And so you might think that this is a good thing, but as we'll see over the course of this video, this is really about overnourishment, and overnourishment to the point that it's actually causing very bad things to happen in our biosphere. So the general idea, we've already talked about things like nitrogen and especially phosphorus being a rate limiting factor for how fast plants can grow. We talked about that in the nitrogen and the phosphorus cycle videos. And because of that, we humans have added a lot of nitrogen and especially phosphates to plants in order to grow them better, because we need the plants to live, to have more food. So what has happened is, so let's say that this right over here is some land, and this is, let's say that's a farm right over there on the land where we're growing our crops. So these are all the crops that we're growing. And in order to ensure that the crops grow as much as they can, we add fertilizer to it. And a lot of that fertilizer, it might be nitrogen, it might be phosphorus in the form of phosphates. So we add fertilizers. And the biggest culprit here, it tends to be phosphates, the phosphorus in them, and that helps the plants grow more. That helps the plants grow more, and which seems like a good thing. But there's another side effect that happens because of this. As the water, either due to rain or irrigation for the crops, as the water flows from those crops into local streams and rivers, and it'll eventually find its way into local streams and rivers, those streams and rivers and lakes are going to have an excess of those fertilizers, in particular, maybe those phosphates. So you have more phosphates in this. Let's say this is a lake of some kind. So I'll make it big. Let's say this is a lake of it. And we already know that things like phosphates are the rate limiting factors for plants. And so you could have photosynthetic organisms like algae in this lake. And if they didn't have the fertilizer, you might just have a little bit of the algae. But now, since they're getting all of these phosphates, the algae can go crazy. The algae can go crazy and grow all over the surface of the lake. And so this is where that algae is getting overnourished. It's getting way more phosphates than would have typically happened just if there wasn't fertilizer, if there wasn't this runoff happening. And it's not just fertilizers. Even some detergents in the past, you have sodium phosphates, which once again can cause this eutrophication. And you might say, okay, well, why is this bad? It could just make the surface of the water a little bit less clear, a little bit green. But hey, there's living things here. Well, the issue is what happens once this algae dies. Because once this algae dies and it starts to float down, that can be food for bacteria. That could be food for bacteria. And as the bacteria consume it, they also use oxygen. We've already talked about the role of oxygen in respiration. The bacteria will consume all of the oxygen in the water. Now, a lot of times when we think of ocean animals, so when we think of, I'll just draw a little fish here. And so that's a little fish. We don't often think about the necessity of oxygen in the water, but ocean animals need oxygen just like we do. And they get that oxygen, waves can crash, and as the waves crash, it brings in oxygen. It brings in oxygen from the surface that ocean animals can use in order to live, in order to do their respiration. But now all of a sudden, if this bacteria, because they're able to decompose all this algae that is dying, if they're consuming all of the oxygen, well, it depletes the oxygen from the water so that the ocean animals can't live there anymore. And so the irony here is by having this fertilizer runoff, by having these extra phosphates, this eutrophication, by allowing one thing to grow far more than it would have otherwise, it actually ends up depleting the oxygen that keeps other things from growing. And it actually creates what we call dead zones. So this fish is going to die, and other animals like it aren't going to live because there's not going to be enough oxygen in that water. And then we have a dead zone. And this is a serious problem. We have some pictures here. This is this is potential eutrophication right in this picture. Let me show you some more. This is another one, and you've probably seen this, especially places that might have sewage runoff. It's really happening because there's extra nutrients that are allowing these algal blooms, or algal, I don't know, to go out of control. And when they decompose, the bacteria is sopping up all the oxygen, and nothing else can live. And this is happening on a macro scale. So right over here is kind of a global picture of dead zones that we have, and you see them all through the world, and you see they are typically concentrated where we have more industrialized nations, where we have either more agriculture happening, and especially you could think more industrial agriculture, where they might be using more fertilizer, and also where you might have more runoff from cities that will have nutrients like the phosphates that will cause this eutrophication to happen. And if you were to zoom in, let's say on the Caspian Sea, you can see this in more detail. You can visually see this. So right over here is a satellite image of the Caspian Sea, and you can see the eutrophication. You can see these algal blooms throughout this area. It's making the water less clear. So this is a serious ecological thing that we have to think about. On one level, phosphates and fertilizers, nitrates, it seems like a good thing. It's helping us grow more crops, but we have to be very careful with where it actually ends up.